This lesson is on the extreme value theorem, and what the extreme value theorem says is that if you have a continuous function that's on a closed interval, then it has both a max and a min on that interval. And again, the key thing here is that we're on a closed interval, so I want to show you some different scenarios. Okay, so again, being on a closed interval is saying that we start at some point A and we end at some point B. And so we're just looking at a section of some graphs. Some graphs, that's all that exists, but sometimes, you know, we might have something that looks like this. And on this interval from A to B of this particular graph, if it would stay there, we will have a max that we normally think of as a max and a min that we normally think of as a min. That is one scenario. Not all graphs obviously look like a cubic or some kind of trig function. Sometimes they have a different shape, so let's look at something that might have been a parabola. So if we look at part of a parabola, they don't always, you know, have to give us a section that is starting and ending at the same y value. So let's try that one more time. So let's say that this is our function and we start at A, we end at B. In this case, you're thinking, okay, well, we just have a max right here. But that's not true, because they're telling us with this theorem that every interval has a maximum value and a minimum value. This is where you start to think, okay, well, our maximum value would be the highest point on that graph. Our minimum value would be the lowest point. So our lowest point is actually right here, and this would be the minimum value. So we're saying it doesn't have to be the top of a hill or the bottom of a valley. It can be this end point over here. That could be the lowest on the graph. But again, not all graphs have curves like these two. Sometimes you have something that is more like a straight line. So let's say that we had a linear function. Well, you're not going to find the top of a hill or a bottom of a valley here. Your maximum is just going to be on one end, and your minimum is going to be on the other. So that is another possibility for this type of thing. Okay, so what we basically need to gather from this is, for any function that's continuous and that gives a closed interval, the maximum or minimum value can be somewhere that the derivative is 0, like here, here, or here. But it could also be the end point, because we need to consider what those values are sometimes to be able to tell whether they're the highest or lowest. So I wrote that up here, how to use it. If they ask for an absolute or a global max and min, or a max and min that is on a particular interval, you want to check where your derivative is 0, because that would give you what we normally think of, hills and valleys. And you want to check the endpoints. You want to know what those values are, those y values are at each of those places, to be able to determine which is the highest or the lowest, whatever you're looking for. Okay, so we're going to do this example where we want to find the global max and the global min for this function, and I made an easy one so that we can kind of get the idea of what's going on the interval from -1 to 2. So the first thing that we always want to do is find any place that the derivative might be 0. And so if I take the derivative would be 2 times -1, so -2. And if we set that equal to 0, that's not ever going to happen. So you don't have any hills or valleys, which makes sense, because if you think about this, this is the equation of a line. So you don't have any hills or valleys. So what you do is you consider the endpoints, because one of them has to be the highest and one of them has to be the lowest. So I'm going to figure out what f of -1 is and what f of 2 is. And so f of -1 would be 2 times 3 minus -1, which would give us 8. And then our 2, we would get 2 times 3 minus 2, which is 2. So we have a maximum at -1 because that's what gave us the highest value. Okay, and a minimum at 2 because that's what gave us the lowest value. Now, they might say, what is the maximum value? And if they said, what, then they would be asking for the 8. Or what is the minimum value? They would be asking for the 2. If they say where, they're asking for the x value. Okay, let's do one that's a little bit more complicated. They want us to find the global max and the global min for this function on -1 to 1. So again, I want to start by finding any place that would be what I would consider the top of a hill or the bottom of a valley, and I find that by finding where my derivative is 0. So take my derivative, I get 2x plus 2, set that equal to 0, and I get -2 equals 2x. If I divide, x equals -1. So x equals -1 is a max or a min, or a flat spot on that graph. But if I'm trying to find these values, I need to find out what its y value is and what the y values are at the end points. That one actually happens to be an endpoint. You don't have to write it twice. So I need to find these two places. Had this endpoint been something different, then I would have 3 things I would be plugging in over here. So when I plug these in, I'm trying to find the actual y value, which means I need to be in the original, in the f equation. So -1 squared plus 2 times -1 minus 4 is going to give us -5. And then f of 1 would be 1 squared plus 2 times 1 minus 4, which would be -1. So I have, so f, let's write it as a sentence like you would on the AP exam. F has a minimum of -5 at x equals -1 and a max of -1 at x equals 1. So the minimum values are, or the minimum values is -5, the maximum value is 1. The minimum occurs at -1, the maximum occurs at +1. Okay, and we're going to do another one with some more to it again. Again, we want the global max or min, or absolute max or min for this function on the 0 to 3 as our interval. So again, set your derivative equal to 0. So take your derivative, which would be -2x plus 3, set it equal to 0. And I would get 2x equals 3, so x equals 3/2. And again, this is a place, as we were just doing in previous lessons, where we did a number line, and that was either a max, a min, or a flat place. So it's one of those things. But because we're finding the global on a restricted interval, I'm going to find out what f of the 2 endpoints happens to be. And I'm going to find the y value at the critical point we just found. So I need to test the endpoints and the place where my derivative was 0. If I plug in 0, obviously I get out 0. That one you can probably just do in your head. If I plug in 3, make sure that you square it before you do the negative. And I get, again, a 0. And then if I plug in 3/2, I have to square that, get 9/4, that'll be negative. And then 3 times 3/2 will be 9/2. And if I add those, I'm going to get 9/4. Now, this doesn't always happen where you get the same y value out, but if it does, it just means that there's 2 places that are, obviously in this case, a minimum because 9/4 is bigger than 0. So we have minimum of 0 at x equals 0 and x equals 3. And we have a maximum of 9/4 at x equals 3/2. Okay, so the lesson to be learned again is to test both endpoints and any place where the derivative is 0 in that original function, because that original function is what gives you a y value. And then again, the last thing I wanted to remind you is if they specifically say where is the minimum or where is the maximum, you want to answer with the x value. If they say what is the minimum or what is the maximum value or find the maximum value, that's a y value. If they ask for the whole point, you need it to look like a point in x and y. So just make sure your answer fits what they're asking. If we went back to the way this question was worded, find the global max and the global min, I would cover all my bases because it wasn't clear whether they wanted x or whether they wanted y. They seem to definitely want y because that would be the maximum or minimum value, but they might have wanted the whole point. So I would cover all my bases there just to make sure I reached all the points that were necessary. And that concludes this lesson.